George, Hannah, Iris, Jacob, and Kim have playoff tickets for seats A3 to A8, correct? And we said, how can we do that without any restrictions? So we put 6 in the first, then 5, 4, 3, 2, 1, and we got 6 factorial, which made sense because we left the human behind, right? I pretended I was holding them. I'm holding the humans and I throw a human up there. Okay, so B, however, made it be that George and Hannah had to be together. And it didn't say George on the left and Hannah on the right. It just said they had to be together, correct? So how did we do that? Well, we hooked George and Hannah together. There's chairs at the front. And so we said, well, 2 could be in the first blank because that's George and Hannah, and 1 could be in the second because we would have sat down George and Hannah. I seriously just talked about phones, but I feel like I'm talking to brick walls. Brick walls. All right. So 2, then 1. Then, now we have what? How many left? 4, 3, 2, 1. And then we would be done if it said George and Hannah at the front. But it doesn't say George and Hannah in the front. It says George and Hannah together. So we could move it 5 places, which is always 1 more than the 4. Okay? All right. Pencils down. Just using brains. Pencils down. Just using brains. Hello?
So how's it a 5?
It's a 5 because we can move these guys. They can be here, which is 1 way, or here, which is 2, or here, which is 3, or here, which is 4, or here, which is 5.
Okay.
And Katie, it's always 1 more than this number after the hooked together numbers. Okay. Nothing in her hands. Once Katie's done that, she's going to put her pen down too. Okay. Conundrum. I'm not telling you how many people are in this class and you're not counting us. I'm going to say how many people are in this school but not in this class. Okay? Would the fastest way to do that be to go down to Mr. Baldwin's room, start counting his, and then be like, is anyone in the bathroom? And then turn directly, and you're at Miss Lyons, and you're like, how many are in your class? And then be like, Miss Lyons, is anyone in the bathroom getting a drink of water, perhaps a Band-Aid? And then you're like, okay. Then I'm going to switch to Miss Patrick's. I don't remember who's all in the end of the hallway. But you work your way through, and you add them all up. Then you come up here, and then you're like, Miss Lepp, how many are in here? Blah, blah, blah. And you're like, wait, we don't have to count you. You're the only ones we don't have to count. And we figure out how many people are in this school. Is that the most productive way? No. Okay. So, if I ask you, how many ways can George and Hannah not sit together, is the most productive way to actually try and do the 7,000 cases where they're not together. I start here, then 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 here. So then why do you guys do that on a test? Stop. Don't do that. That is not the productive way. That is equally as bad as walking to each class and adding them up. What would be the fastest way to decide how many people are in this school but not in this class? Yeah. And ask them, you could ask them, hey, how many kids are in this school? And they'd be like, blah, blah, blah. And then you say, hey, Mrs. Lepp, how many kids are in this class? And I'd say, blah, blah, blah. And then what would you do to them? Subtract them, wouldn't you? So let's keep that in mind for C. Let's look at C. C says, C's on below yours, but mine bumped to the next page. C says, just before the game, George and Hannah had a disagreement and decided not to sit together. How many ways can that happen? I'm going to star this one because it's one of the ones that's forgotten. Remember how I told you star, star, star because you will forget? Here's one of them. Okay? The best way to do this question is to not try and draw all the cases where George and Hannah don't sit together, because they could be in the first and third, the second and the fourth, the first and the fifth, the second and the fifth, the third and the fifth, the second and the fourth, and then swap them. There's a whole bunch of cases, right? That's not the most productive way. The most productive way would be hey, how many ways can I rearrange them total? So this would be total no restrictions. How many ways can I rearrange them? Total no restrictions. The absolute maximum number of ways that these 6 people could sit. That's what the total no restrictions is. Yeah? It would be 720. It's that 6 factorial that we just did at the very first one. The total no restrictions would be, here are my 1, 2, 3, 4, 5, 6. I can put 6 people here. Then I sit one down, 5, sit one down, 4, 3, 2, 1, which is 720. right? Now that is the absolute maximum number of ways I could rearrange those 6 people. It was 6 people, wasn't it? Yeah. Those 6 people. That's the absolute maximum number of ways I could rearrange those 6 people and have different people sitting on sides of each other, correct? So could I find a 721st case? Could I find a 721st case? No. 720 is the absolute max. Okay? So if I found the absolute maximum number of kids in this school and I subtracted the people not in this class, I would have left over all the people in this school that are not in this class, correct? So if I take the total number of ways I can rearrange all those people without restrictions, which is 720, and I subtract off all the ways that George and Hannah are together. Look at Hannah. I look, I'm making it up. Yeah. Are together. What will that be left over? If I take all the ways total minus the ways that George and Hannah are together, what's left over? George and Hannah not together. Because what's the opposite of George and Hannah together? George and Hannah not together. So if I take the cases where they're together and not together, I should get the total, correct? So once again, how do I do the George and Hannah together? Oh, wait.
Is that a compliment then?
Yeah, they would be compliments. George and Hannah are together. Well, I would go 1, 2, 3, 4, 5, 6. I would hook George and Hannah together. How many options do I have on the left of this one? 2. Someone whispered it. I heard you. 2. I hate this board sometimes. 2. Then how many are left for this blank? 1. I sat down George or Hannah. Now I sat down 2 people. How many are left for this blank now? 4. Then literally 3, 2, 1. Then am I done? Is that all the ways George and Hannah can be together? That's all the ways George and Hannah can be together on the left. What do I still have to remember to multiply by? 5. Because they can be here, which is one way. Didn't change. Awesome. 2, 3, 4, 5. So multiply by 5. So it's going to be 720 minus 240, which is 408.
On the test, could we just use the 240 from the last question?
If I did A, B, and C, I would expect that you use the 720 from the A, the 240 from the B, and get me the answer for
So
C.
we wouldn't have to show that?
Absolutely not. Yeah. But if the question is just George and Hannah not together, you'd have to show all the work, like if there was no A, B. Yeah. Okay. I want you guys to try this Canada. What's the very first thing you do when you get a word? Rewrite it and see if there are double ups and triple ups, duplicates, stacking letters, any of those options I will take. Start it out, and you're going to try A, B, C, D. That's it. Try out example 6. Very first thing we're going to do when we get a word is we are going to go C, A, N, A, D, A. Canada. Okay, I'm going to go, okay, these are all using Canada. 3 factorial. 3 factorial. 3 factorial. Okay, then it says Canada is 6 letters, so I have to put the 6 letters down. 1, 2, 3, 4, 5, 6. It has to begin with a vowel and end in a consonant. How many letters in Canada are vowels? 3. A. And how many are consonants? C, N, and D. So 3. How many letters have I put in there now, though? 2. How many do I have left? 4. So I go 4 here, leave 1, 3 here, leave 1, 2 here, leave 1, 1 here. And then I get what answer? Thank you. The next one says, must begin with C and D in that order. Must begin with C and D in that order. 1, 2, 3, 4, 5, 6. And it has to begin with C and D, so this is a C, this is an N, this is a D, and they can't move. It has to begin with those, right? It doesn't say together, it says begin with them. So it's 1, 1, 1. Then I have 3 letters left, 2, 1, which actually is an answer of 1. The next one just says C and D must be together. And then in that order. But they have to be together. They don't have to start with C and D, right? They're together in that order. So we have 1, 2, 3, 4, 5, 6. So it has to be C and D, but together. So I hook them together, right? And it has to be in that order. So I still have 1, 1, 1. And then I still have 3 letters left, 2, then 1. But what do I have to do? Times it by 4, because there are 4 spaces I can move it. Correct? It's always 1 more than this number. Make sure I extend my line. Now make sure that your 3 factorial, you see that 3 factorial? Make sure you have a full numerator and then denominator 3 factorial. Don't have like a little line and then you have like numbers floating above this non-existent line on the sides. Just draw a whole line. Use up your whole pencil. I don't even care. But from the first number here to the last one, we need to have a full line across it, okay? Don't just do like and then have stuff over here, and then this 3 factorial. That's not actual legitimate math. That's just weird. So if you're doing that, stop the madness. Okay. So we have an answer of 4. And then this last one, C and D must be together in any order. So I'm going to have 1, 2, 3. These ones have to be together. 1, 2, 3. So I have 3 options for this one now because they can be in any order. It can be C, N, or D. Leave one there, 2. Leave one there, 1. Then I have 3 letters left, 3, 2, 1. And if it said be together at the front in any order, I would be done, correct? But it says be together. So how many more places can I move this? 4. So I can go here, 1, 2, 3, 4. And it's always 1 more than the number after the hook together numbers. So you should have got an answer of 24. Okay, I'm going down to example 7. Oh, I hate this book. Okay. Example 7 says, Julie's home is 3 blocks north. That means up. Never eat shredded wheat. Julie's home is 3 blocks north and 5 blocks west of her school. So here's her school. Her home is 3 blocks north, 1 block, 2 blocks, 3 blocks north, and 5 blocks west. West, never eat shredded wheat. 1, 2, 3, 4, 5. Here's her home, and then it just makes a box. It's a pathway system. Okay. Now, yeah. After this, just so you don't miss this, okay? Okay. Unless you have to. Then go. Okay. So we have home and we have school. Home is 3 north and 5 west of the school. We agree? So there's a pathway system. Now most like pathways aren't perfectly like rectangular or square like this, right? But even if they jolted around or up or whatever around, it would still be one pathway to the left and up and left and up and left and up or whatever. We have to figure out all the different ways Julie could take from home to school if she always travels either south or east. So she either has to travel technically right to go east or down to travel south. Now you can actually count the pathways and do it that way, but it takes longer. Whenever you see a pathway question like this, you can think of it as a repetition of letters, okay? So she technically has, she can go east or south. So she technically has east, 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 or south, south, south. Those are the options she has. At some point in time, to get from home to school, she's going to have to go east 5 times and south 3 times, correct? She could technically go east, 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 then south, 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 and take the whole outside path. Or she could go south, east, south, east, south, east, 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 right? But no matter what, she's going to have to do 5 easts and 3 souths somehow, out of different orders, to get me to the school, correct? Okay, so she's going to have to do 5 easts and 3 souths in some order. Now, does it say she has to go east first? Or that she has to go south first? Does it say anything like that? So I'm just rearranging 5 easts and 3 souths with no restrictions, correct? So I technically have the word, I can pretend it's a word. I could have E, 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 S, S, S. How would I rearrange the word east if there was no restrictions? In the denominator, I'm going to have what? What am I going to have in my denominator? 5 factorial and 3 factorial for the 5 e's and 3 s's. The top is no restrictions, right, Matt? Totally. I don't think you distract yourself, distract someone else. On the top, what would I have? Eight factorial. Yeah. Because you'd have the 8 blanks, and you could put 8, then 7, then 6, then 5. Like if I had the 8 blanks, 1, 2, 3, 4, 5, 6, 7, 8 on the top, I could either use all the easts or souths first, but then I went east or south, correct? So now I have 7 directions that I could go. Then 6, then 5, then 4, then 3, then 2, then 1. Right? Because here I have all the options that I would go. So let's pretend. I have all the options. I'm actually going to go south first. Well, now I have 5 easts and 2 souths left. Now I'm going to go east. Well, now I have 4 easts and 2 souths left. Then I'm going to go east. Now I have 3 easts and 2 souths left. Then I'm going to go south. Now I have 3 easts and 1 south option. I go east. Then I have 2 easts and a south. I go south. Now I only have 2 easts left. So in the end, you have to take one of the pathways, right? So when it's a pathway system, the easiest thing you can do is the top is just all the directions factorial over the doubling and tripling, right? Or in this case, 5 before. Make sure everyone is typing this into their calculator and practicing. Every single one of you is practicing this because I want to see that you can get the actual answer.
Thing again on the
Oh, you go alpha, y equals, and then n.
You don't need to put the brackets on the bottom, guys, so you can.
No, I just use the fraction. Yeah, if you use the fraction, you don't need the bracket. So you should be getting 56. So whatever method you chose, you have to be getting 56. If you got 56, you can continue to use the method you chose. If you do not get 56, you did something wrong. You should call me over and we can figure out what you did wrong. And if you have the TI-83s, you don't have a choice in method. You do 8 factorial divided by the bottom in brackets. Every single time you don't have a choice, there is no fraction button. Okay. We go to example 8. Oh, good. It is part of it here and part of it. How many? I don't know why I just drew dots there. Anyways. We have the bus station to the concert hall. Okay. So this one happens to have 2 rectangles, correct? So here it has a supervisor of the city bus department is determining how many routes there are from the bus station to the concert hall. Determine the number of routes possible if the bus must always move closer to the concert hall. So that just means east and south. So what I want you to do is find each of these boxes separately. So this one's going to be the word E, S, 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 S. Find that one out. Then this one is going to be the word E, S, S. Calculate that one out. So do both of them separately for now, because we have 2 boxes this time. We're going to be taking these pathways and these pathways. So you're going to find the answer to E, S, 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 and you're going to multiply it, because we need to AND it, to the answer of E, S, S. So find this one separately, just like we did the top one, above this. Find this one separately, just like we did the top one above it, and multiply your answers. So, how do we do these? Well, we have 3 E's and 4 S's for the first one. So we're going to have 3 factorial, 4 factorial. Now I'm telling you that you have to do these separately because if we were in Okotoks, this would be like Westmount. There's pathways in Westmount, and its sister community, Cimarron, is over here. And we have to do the pathway system in Westmount to get from whatever to whatever. Then we cross over into the community of Cimarron from there to there. We have to find each pathway separately, and then we're going to multiply them because we need these paths in Westmount and these paths in Cimarron. Somehow that erased that. I don't even know. I just covered my hand over it. Huh. Would that be cool if that actually worked? When you want it to do something. How did that happen? Force within the field. Physics. Yeah. No. It just erased that for no reason. I have no idea why I erased it, and I don't know why it's back to blue. But whatever. Cool. Okay. On the top, we're going to have how many? 7 factorial. Oh, no, it's back to black again. Perfect. And then here we have 3 factorial, 2 factorial, and what's on the top? 5 factorial. And what do we get for an answer? Total, sorry. It was 3.
Oh, 350.
There we go. 35 and then 10? Is that what it is?
Yeah.
Yeah.
First was 35?
Yeah,
Okay.
35.
All right. Paying attention?
Yes.
Are you okay?
Yeah. I'm just a little disappointed with this.
It says your turn. Shockingly, it's your turn. Now, look, there's 1, 2, 3, 4, 5, 6 questions. Okay? When I release 6 questions unto you, at about question 3, we have some people petering out. I can't have that. I believe in you today. You have tomorrow off for Truth and Reconciliation. You should go find out about it. At least, yes, that's what we did last year. There's tons of stuff in Okotoks, just so you know. There's tons of stuff. You can go to like, last year we went to the museum. What else did we go to? Oh, we went to the actual spot of the, there was a residential school right outside of Okotoks. Did you know that?
Really?
Yeah. There's a spot, you can go look at it. The residential school's not there anymore, we already talked about it.
Which direction?
Towards the winter.
Was there like,
We're going to do combination lessons. So here we are, it says how many different ways can the words incorporation? So we go C, O, R, P, O, R, A, T, I, O, N. Can be arranged so that the vowels always come together. So it has 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Make sure you have your multiplication symbols. And on the bottom you have 3 factorial, 2 factorial. Okay. Yeah, I body checked it with my arm. I felt it. Okay. So, the vowels have to be together. How many vowels are there?
3? No, that's wrong.
Nope, you gave me the right answer. Yeah. I was like, you had it right. So there's 5. So we have 5, 4, 3, 2, 1. Then we have 6 letters left. 6, 5, 4, 3, 2, 1. And then it says together, so I can multiply by 7. One more than the number hooked together. Make sure my denominator's over the whole thing. And what do we get? A, B, C, or D? C. The next one, it says how many arrangements. It's a word. Arrangements are always going to happen. Words are always permutations. Made of the letters in the words in engineering. E, N, G, I, N, E, E, R, I, N, G. There's lots on the bottom of this one. So there's going to be a 3 factorial, 3 factorial, 2 factorial, 2 factorial. And it has 6, 7, 8, 9, 10, 11 letters. So I'm going to put 11 factorial on the top. I could do 11 blanks and go 11 times 10 times 9 times 8 times 7. But if there's no restrictions, you can always just take the number of letters factorial and put it on the top, correct? What's the answer to this one? C. It is. Look at those eyes. She's like disgusted with me. It's fine. Okay. We have kitchen. Does kitchen have any doubling or tripling letters, Mac?
No.
No. Okay, cool. Now it says the letters KCN must be together in the order KCN. Help me out.
So, 1. 1.
We draw 7 blanks first. Why are we doing 1, 1, 1?
Guess I gotta be in that order.
Okay. What else do we have to do?
4.
Ben? You have to hook these together. It says they have to be together. Does it say they have to be together at the front?
No.
No, it says together.
No, and then I times it by 5.
And you times it by 5. So it's going to be 120.
Here we go.
You paying attention?
Yeah.
Okay, I don't believe you. All right, we have the letters KCN must be together, not necessarily in that order. So we get the exact same thing, but the first 3 blanks are not 1, 1, 1 anymore. Mac, what are they? 3, 2, 1. We have 3, 2, 1, 4, 3, 2, 1. We still multiply by 5 because it doesn't say at the front. And we will get 720. This one is like the seated together ones. We're paying attention? Yes?
Yes.
Okay, stop sidetracking. Anne, Brian, Colin, Diane, and Eric go to watch a movie and sit in 5 adjacent seats. How many ways can this be done if Brian sits next to Diane? I want to call him Brian. Brian sits next to Diane. Now, does it say Brian has to be on the left and Diane on the right? For those of you who are on your phones and your phones are on your lap and you think I can't see you, there's at least 4 of you doing that.
What?
What? Shame.
I just thought my chair looked really...
I was not talking to you.
Oh.
Okay. He didn't have his phone.
Sorry, I'm-
Okay. So we have 1, 2, 3, 4, 5. It doesn't say Brian has to be on the left and Diane on the right or anything like that. It just says they have to be side by side, which means together. So we have how many options for the first blank? 2, then, and we have to multiply by 4 because there's 4 spots they could move, which is going to be 48. So there are 48 ways that this can happen. Then it says Anne refuses to sit next to Eric, which would be equally as the same numbers as if Brian, why do I want to call him Brian? Brian that refuses to sit next to Diane. It would be the same thing, right? We would get the same thing. So we have to do total no restrictions minus sitting 2 of them together. So total no restrictions of 5 people is 5 factorial, and then minus 2 people sitting together, which is 48. So that's 120 minus 48, which is 72. Good answer. All right. Then we have, determine the number of ways anteater can be arranged if A, N, T, E, A, T, E, R. If the word begins with a consonant and ends with a vowel, before I even do that, I'm going to go 2 factorial, 2 factorial, 2 factorial in the denominator. Because I have 2 A's, 2 T's, 2 E's. You guys are so cool. Now, it has to start with a consonant and end in a vowel. So we have 2, 4, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Begin with a consonant. How many of these are consonants? 4. N, T, T, and R. So there's 4 of them. How many are vowels? 4. She said 4. You could roll back the tape. You could hear her. She said 4. Now, how many letters are left? 6. Then? 5.
4, 3, 1. Did you count? 0. Sorry.
So we have 16 times 720 divided by 8 is 1440. Then we have the consonants must be together. So we still have 2 factorial, 2 factorial, 2 factorial in the bottom. Then we have 1, 2, 3, 4, 5, 6, 7, 8. How many consonants are there? There's 4. Does it say what order? No. Does it say they have to be at the front? No. But they do have to be together. So we start with them at the left. 4, 3, 2, 1. How many letters are left? 4, 3, 2, 1. And then I have to multiply by 5 spaces that they can move. So I'm going to get 24 times 120. 102. 24 times 120 divided by 8. 360. The pathways questions, if you didn't complete them, they have to be completed for Monday. I will walk around and look at one question. I will. And then we're going to go through it. So, only thing that changes on B as opposed to A is what? Oh, I keep pressing this.